Good afternoon, everybody. So I'm Timo Korhonen from VTT, and Timo already told what VTT is. So today I will speak about FDS+Evac and, well, more or less the latest developments in it. And, well, some of the developments are already in this FDS 5.5.3, so you can use those, but some are in the source code, so you should compile it and run it. First, small background on FDS+Evac. So it's continuous space and time type of model, I guess like Pathfinder also. You can have many floors, and of course, because it's inside FDS as subroutine, it can use smoke and other toxic gas information from FDS. And nowadays it can even, well, last 2 years already basically, has been able to model counterflow, whereas the original model by Helbing was not actually very good for counterflows, as you can see. So it's based on so-called social force method or the panic method of Helbing, which basically just is used to keep interperson distances in the crowd so that you are not overlapping too much each other. And same kind of force, which is the basic form is just the exponential. Well, the choice for exponential actually is not very good for computers because the exponential function is really slow to calculate with computer, but, well, one has to live with that fact. And actually, FDS+Evac used the angle-dependent social force, so it's different for the back and front of you. And human body is modeled with 3 circles, which more or less makes it elliptical body shape for this 2-dimensional geometry. So what are the recent developments? Well, nowadays if you are using FDS+Evac, you should put many input lines in the FDS file, and some things you should copy and paste many times and change a little bit, so it's not very user-friendly. But nowadays, it's going to be in this next released version of FDS, whatever it's going to be, if it's 6 or 5.5.4 or whatever. It's already in the source code, so next time some FDS version is released, all these things are inside it. So to put the doors, it's now much easier, and there is a staircase model for the whole staircase. And now it has actually, per one floor, it has 2 levels. One is for movement, so you cannot move through this thing, but you can see over it. So it uses different set levels for seeing and moving. And that's good for spaces like auditoriums, where you can see over the chairs. And in quite many places you have lots of glass also, glass walls, and you can see through those. And actually nowadays there is a little bit better wayfinding algorithm for visible doors. Original version of FDS+Evac used calculated flow fields to go to the doors, so you were not, if you are alone in the hall, and so you walk directly to the exit. But in the old version you were most flowing around a little bit. But that's now better for the visible exits. And then you have some behavior things added to the model, how people choose which exit they will go. So some herding behavior, and then you can have lost agents. So if they don't know where to go, so they try to see where other people are going and just follow. Here's an example of the easier user input. It's all you need for, actually I show in the next slide which kind of geometry you get. But the basic thing now, you need one floor of the building, you need only one evacuation mesh. Well, then you have the timeline and then some obstacles making your geometry. But then you need just to specify where your exit door is. It's just one line. Earlier you need to input additional meshes and outflow vents and all kind of these things, but now just one exit line is enough and everything is done automatically. So it looks quite simple. You just get the FDS geometry, add additional evacuation mesh on those levels which you want, and then just put exit or door lines. And then of course you need describe the personal properties, for example, pre-evacuation time and detection time distributions. And of course you need then evac lines to place your initial population in the building. Those you cannot make automatic because it's user input. So with that kind of input you get this thing going on. And here, actually if it runs once again, you can actually, if you are seeing, so they are more or less going directly towards the door, actually towards this green cone. And there you can see that you can have obstacles which are blocking movement or blocking visibility. Well, usually in buildings you are not having this kind of things, but just so, or then you can block the visibility or the movement. So this thing is good for auditoriums, which was not so nice to model in the old version. And then you can model the staircase in just one object, but it has more or less limited geometrical things, so every floor of the staircase should be the same geometry. And it's more or less like you have floor level, then stair flight, intermediate landing, next flight, and quite typical stairs. And it can detect your doors and exits automatically. So this, if you have, it checks, you say the section where your stairs is, and it finds the doors which are more or less touching the staircase. And the users do not need to give input to which floor the agents are moving inside the stairs, so it knows the target exit door out of the total building and can figure out which floor they should go out of the stairs. And actually, this model was basically done by actually Timo. So to define a stair, you just need one line where you say more is xb, so give the coordinates, width and length. And then you say in the middle of the stair flights you have some railings or concrete block or whatever. So you give it, and then you give the landing sizes. And if you are going right-handed or left-handed, and that's all you need to give. And of course, number of floors. And then how fast you go up, how fast you go down, and how fast you go on horizontal. So that makes it much easier to make staircases in FDS+Evac. And one benefit of modeling the whole stairs is that you can use the full crowd dynamics of this social force method, and you don't have to have any artificial door-to-door connection within the stairs. So then you can have people moving in two different directions in the staircase, and it's following those people like in horizontal floors also. And this I already told something about the movement versus visibility. This is more or less quite new added thing. So this is not in FDS 5.5.3 yet. So the basic geometry for evacuation, you just specify some lower bound and upper bound for set dimension, and you cut your geometry and you get obstacles for movement. And if you are not happy with those, you put other obstacles there. And then it takes a little bit more or less, by default, more or less head height. So about 1.6 meters above the floor level, and then plus minus 20 centimeters or so, which are taking for the visibility. In this case, you have a bookshelf here, which goes to the visibility, but table doesn't show up in here. And this is good for also the door selection algorithm, because people try to select door where they can go fast out. And there it's better to treat the visibility correctly. And then one quite recent things are some added human behavioral modes in FDS+Evac. So in common observation in building evacuation is that you are not going to use all available exits. You usually prefer familiar routes, and also you follow others quite often. But usually these are not, at least not included in building codes at least at the Finnish code, where it's just enough to have the total exit width, and that's all which is required. But in real cases, it's one evacuation drill in Finland, and actually this was some kind of office bill or some kind of, and you can see that they are mainly using this side. There are two double leaf doors going out, but they were using basically this one side. And now coming back, they are much more efficient. So they are hurry back to their office to continue their work. Outside, they were not in a hurry. And you could see that in quite many cases, they just use one half of the door, one leaf, because it's already open, it's easy to follow. And all these kind of things you can see in real evacuation. So the door usage is not going to be, in real case, always optimal. And these kind of things, to model, there are different human types now in FDS+Evac, so you can model like staff members or regular crowd members and so on. So there are actually now 4 different kind of agent types in FDS. One is conspiracy agents, or the old type which is in FDS+Evac, which tries to choose the best door which they can find, so which they have preference list that they prefer known doors, and then they prefer also visible doors. And if there are similar doors, but there are people queuing in one door and one door is empty, they choose the empty door because it's fastest. But then now you can have also active agents which more or less, they don't care if the door is known or visible, so they more or less know every door. So they use the fastest way always. Then you can have herding agents which basically don't decide which door is fast, which is not. They just see nearest neighbors around and follow those wherever they are going. And then you can have follower agents. They are more or less doing like the old default style, so they choose some door and they go there. And they are quite happy with it, but if they see that the nearest neighbors in their front are going to some other door, so they also think the other door and checking if it's good or not. So they might even go there if it's not known door. So if somebody in front of you go to the emergency exit door, then you start thinking, oh, is it that going to be a nice door for me also? Oh, it's going, and you follow. And here's some simple verification case that you can, these herding agents, well, the big blue ones and red ones were, they were programmed, red ones going here and blue ones were going here, and the small ones, they were just following the others. And as you can see, the gray ones turn to choose some blue door or red door. This was just to show that there are not large programming mistakes in the code, basically. And here's simple verification for the followers. So all the red agents are heading to this door here. And a couple of blue ones initially, their target door was this emergency exit door in the middle of the corridor. And you can see that these follower agents are starting to follow the couple of blue ones to the emergency exit doors. So this gives, for the model user, more flexibility to give different kind of scenarios for your analysis. So to conclude, well, there are these different kinds of modification, and probably the next version is be FDS 6.00. But some things still to do, as always. So, and then there are these different human types which you can use. Actually, you could use them in some other programs also, but I have just implemented them in FDS+Evac. So, thank you. And I should acknowledge VTT and Academy of Finland for funding. Thanks.
Any questions for Timo?
Hi. Yeah. This herding agent algorithm, it almost contradicts what was said before for the Pathfinder, that when you queue and there's another available exit, you go to that other available exit. I'm not saying that either one is right or wrong, but is there enough statistical data out there to determine which one you use on on various scenarios, or is it just another agent to show a picture and use whatever one is more favorable to your situation? I mean, I know it's not a specific science, but how do you know which way do you go?
Well, that's a good question. It depends on your crowd. So if you have frequent fire drills or something, so people, they know what to do and they go wherever they go and do not follow others. So, but if you are in well, in a nightclub, so everybody will go to the main door, basically. And follow others and, well, use the main door. They don't know any other door. But for modeler building designer, you should consider all the cases, and also, well, it might be that in some cases you get long evacuation time, but you should try to design buildings such that it works more or less nicely also in that case. Because you know, and from experience, you know that things will not be always nice, that people are behaving badly. So you should think that when you are designing a building.
Any other questions? All right, thanks.